Hello, my name is Clint Halstead, and this is going to be a tutorial on how to do Lab 3 in Digital Electronics class, ELN 133. So in order to do Lab 3, the main thing you have to do is you have to build this clock source first, which you really haven't learned how to build a clock source. So I'm going to teach you how to build the clock source. The rest of this you should be able to already know how to do based on the tutorial that you did. Okay, so in order to get a 1 Hertz clock, I will show you how to do this block here. The rest of this you will have to learn to do on your own. This is just an AND gate, this is a logic switch, and this is an LED. So the best way to do it is take your intro tutorial folder. Mine is called 0_intro tutorial. If I go inside there, I have all my files, light.bdf, light.qfp. But if I take that folder and copy it and then paste it, that's the easiest way to create a new project. I can call that 2, and instead of intro tutorial, I'll call it pulsed logic. Lab 3. Okay, so when you get done with this lab, you can zip this entire folder, send to compressed zip folder, and then you can upload it to Moodle. But for now, I'm going to descend into that folder, and then I'm going to double click on light.qpf, not light.bdf. If you can't see your file extensions, that means you need to go here to folder and search options, view, and then you need to say, the default is hide extensions for known file types. If you apply that, then all of the extensions get hidden and you can't see the extension. If you unclick this, then all of a sudden they reappear. So that's the best thing to do there. Also notice that they have a different symbol. So we want not this purple symbol, but the blue one here, light.qpf. So now I have my project open. This is the same one that you did before, the tutorial. This is what you get. Okay. So now what I want to do is create a new block, which is this pulsed clock source here. And it's a 1 Hertz signal. Okay, so what I'm going to do is notice that if you go to your board documentation, if you go to maybe perhaps your schematic that's on your CD that came with your kit, you should look around in here and you can see that on page 15, this is the device you're using, EP3C16F484. This is the FPGA. You can see a 50 megahertz clock coming in on pin G21. So that's the clock we want to use because we need to have a pulsed signal according to the lab. Another way to get that information is you can go to the user manual, the E0 user manual that came with your kit. And if you go to page 32, if you browse this, you should look at these manuals, just read the whole thing and get familiar with your kit. You'll notice again that there is a clock on pin G21. It's called clock_50. And you can get there from the contents page. There's all these different contents, and one of the things is clock circuitry. If you click that, it'll take you right to a description of the clock circuitry for the board. A 50 megahertz clock. 50 megahertz means 50 million cycles per second. We want 1 Hertz. That means we want something that's slower than that by 50 million. So we have to divide that signal down by 50 million. Sounds like a lot, but for the digital world, 50 million is not that much at all. Okay, so get familiar with your documentation on your board. It comes on the CD that came with the board. Okay, so how do we do that? If we look at our assignments, an assignment editor, another way you can see the clock signal is you can look there, because if you go down far enough, you'll see clock underscore 50. So since we have these assignments, then we can just use that. Now you had to make sure that you have done the tutorial properly in order to get these assignments. If you haven't, then you can go to the Moodle website, the class website, and you can download those. And those are located on the Moodle site right here, DE0 assignment. So if you download that file into your folder, go to assignments, assignments, import assignments. You can go ... You can point to that file wherever you have placed it. Click there, say open, and then OK, and that will pull that file in so you can use that. So for us, what it means is you can add an input. You can call it clock 50, just like on the pen assignment. Go back to the, you can actually click this as a shortcut to the assignment editor. Clock 50, so it has to have that exact same name. You can also leave this up instead of closing it, and you can just go back and forth using the tab. Okay, so now we have the clock 50. This signal is 50, a 50 megahertz clock. Now what we want to do is divide this down by 50 megahertz. We want to divide it down, count to 50 million. What we need to do that is a counter, and I need to show you how to do that because we haven't talked about counters yet. So you go to add a part or symbol tool, click that. You click Mega Wizard Plugin Manager. Create a new custom mega function variation. Next. It's arithmetic. Go down. LPM counter. Leave everything else the same. One thing you need to do is click here, tab arrow over all the way to the right, and then type a name. Counter. You can be 50 to 1 or 50 meg to 1, whatever you want to call it. Okay, we're going to say, how do you design this counter? Well, you can bring up your calculator, go to the programmer view in Windows 7, type in 50 million, and I'll show you the number of bits down here is, this is actually, the 15 here is actually the 16th bit because you start with 0. So that's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So it takes up to 26 bits. All the rest of these are zeros, which don't really matter. So you need to find the MSB. The MSB is 26. And 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So we're going to put in 26 bits. Up only. We want a modulus. That means it's going to count to 50 million. 1, 2, 3, 1, 2, 3. And hit next, 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 finish. If I ask you a question here, say yes, always do that, and then say OK. we're going to place this clock, so the clock pin is on our clock. Now I'm going to have to show you something else that you have not learned before. I am going to change this because, well, let's see. Go ahead and hover your mouse over the Q25 down to 0 until you get the Kinect tool. Click, hold, drag out. Now I'm going to right click on that, go to properties. We can call that the same name that it has, Q bracket 25 dot dot 0. What that means is 25 bits down to 0, so it's 26 bits. And the 25th bit is the MSB. Okay? Now we want to take that, we want the LED, so we can delete everything else. For your project, you'll want to leave one of these buttons for adding your AND gate. But for now, I'll just delete all that. Now I'm going to add another wire here, but I'm going to go to properties. I'm going to name that the MSB, the most significant bit. Q25 is the most significant bit. So I'm just going to rip one of those bits off of this bus. So this is called a bus. It has a collection of 26 bits. This is just a single bit. Now this clock pulse is divided down by 50 million. And so this signal here on your LED should now blink, you know, at 1 hertz. So let's save everything, and then let's. Now, one thing you may have to be careful with is this property called inst. What this is every component you add to your schematic should have a unique identifier. And what happens, there's a bug in this program, and what happens is sometimes it may call this inst1, and if you have another block or AND gate called inst1, it'll give you an error. And I will show you what that looks like. Okay, this one's called inst. You need to make sure this one is not also called inst. Like if you try to enter it that way, it'll complain. But sometimes the LPM, when you insert it, those names are the same, and if you try to run that, it'll give you an error. And that's just kind of a bug. So be careful if you get an error that says inst1 or inst something, just be sure to go in there and change these reference designators, is what they're called. Okay, so let's compile this. Okay, so it's still compiling. Looks good so far, no errors. If you do get an error, it'll turn red. Just double click that error and it'll show you on the schematic where the error is at. Okay, so now we can program our device and see if it works. So we can double click on the programmer. It should come up. Make sure you have your cable, your USB cable plugged in, and the power switch has to be on. The little blue light has to be on. And you have to make sure you go to hardware setup. If you don't have it on, it'll say no hardware. If you turn it on, you may actually have to go say USB Blaster 0 and then close, and it should say USB Blaster 0 up here. And then click Start. 100% successful. Close it. And then you can look to see that your light here is blinking. So at about 1 hertz, or 1 hertz is, once per second. So now you should be able to do your lab, which is like an inhibit type function where if you push a button, the light should stop blinking. So you should be able to do your lab now. Alright, that is it, and I hope you have good luck on your lab.